All right, so now we're going to start section 3, excuse me, section 5.3. In sections 5.1 and 5.2, we talked about given an X value or a Z-score, how to find the probability associated with each of those values, given the mean and the standard deviation. In section 5.3, we're going to go in reverse. So the goal is to determine a Z-score or X value associated with a given probability. So let me remind you of what happens in the normal curve. Inside the normal curve, you find probability. Outside the normal curve, you find Z-scores or X values. And to go from the outside in, so when given a Z-score or X value, you use the normal CDF function to find probability. So if we're going to go in reverse, if we're going to be given probability, you do what you would do in any situation in math. If you want to go in reverse, the opposite of addition is subtraction. The opposite of multiplication is division. Those are called inverse functions. So if you look at the calculator and you go to second vars, you'll notice that number 3 says inverse norm. And inverse norm is the inverse function to normal CDF. So that's the one we're going to be using to go backwards. So given a probability to determine a Z-score or X value, we're going to use inverse norm. So up here, that was second vars 2. This one is second vars 3. Now, the inverse norm function is not used as frequently as other functions on the calculator. And so if you have an older calculator, the inverse norm function will not have this extra part here that asks you about the tail. If this comes up on your calculator, just leave it on left because I want everybody doing the same thing. I don't want to confuse anybody by giving you multiple different directions. So if you do have a newer calculator and when you hit second vars 3, if this is what your screen looks like, then make sure the tail is black on where it says left. Because the instructions that I'm going to give you, you're always going to be dealing with given probability to the left of a value. So on a normal curve, to use the inverse norm function, you're going to know what the shaded region is. So this might be something like 0.26. And if your shaded region happens to be to the right, maybe that's 0.18, then we're going to use 0.82. So here we would use 0.26 because it is the probability to the left. But if our shaded region happened to be to the right, we would use 0.82 for our area. So the calculator in inverse norm wants the area to the left of the value, the mean, and the standard deviation. And that way, whether it's a z-score that you're dealing with or a x value that you're dealing with, if you know the probability and you know the mean and standard deviation, you can find the z-score or the x value. So here's an example. If I want to find the z-score associated with this probability, and I'm going to use the one I have it up there, of 0.26, then what's happening is I want to find the probability that z is less than some value I don't know, and I know that to be 0.26. So I'm going to use inverse norm. Area to the left of the value is 0.26. The mean for a z-curve is 0, and the standard deviation is 1. So if we go back to the calculator, you would put in 0.26. The mean is 0, the standard deviation is 1. If, when you hit inverse norm, this comes up on your calculator that you just have the open parentheses, then you'll put the 0.26, comma, 0, comma, 1. You will not need this left part because if you have an older calculator, that's not even embedded into the function. And I get negative 0.64. Negative 0.64. So let's talk about that. That's a negative z-score, which indicates that I'm almost one standard deviation below the mean. That makes sense because if it's a z-score, the mean is 0. I know my line is to the left, so I should have ended up with a negative z-score. Look at that, because if you've got your picture and you've got it shaded and you were to put in the wrong probability, it would give you the z-score on the opposite end. So that's a way that you can evaluate whether what you're doing is correct. So let's look at the second one. The probability of the region shaded above was 0.18. So let me show you what I meant by I want to find the probability of z being greater than some z-score that I don't know what it is. That's what I'm trying to find. I'm solving for z raised to the asterisk. So I'm going to use inverse norm. If you were to put in second vars 3, if you were to put in the 0.18, then you would get a negative 0.91 or negative 0.92. Well, if you look at this, my shaded area is to the right of 0, so it's got to be positive. So that in and of itself tells me that I've done something wrong. That's why you have to do 1 minus 0.18 here. 0, 1, and you can put the 0.82. So when you do that on the calculator, second vars, 3. If I use the 0.82, then I get positive 0.92. So you might say, well, all I got to do is take the negative sign off of it. And that is true, because if you think about it from the perspective of this being symmetrical, if there's 0.18 on the top end, then there's 0.18 on the bottom end. But I'm going to be looking at what you're putting in the calculator. So that's just a way to help you understand, oh yeah, if it's negative, the real correct answer is the positive, but you need to change what went in your calculator to 1 minus the 0.18 instead of using 0.18 and then just changing the sign. So what would you do if you had a problem that said the probability a person is in the, well, no, let me rephrase that. Say a student scored in the top 10% of his class on a test. The test scores were normally distributed with a mean of 81 and a standard deviation of 5. What is the lowest score one could make and be in the top 10%? So I know that my distribution is normally distributed. I know that the mean is 81 and the standard deviation is 5. And I know I'm in the top 10%. So the probability that X is greater than some value that I don't know is equal to 0.10. And I know it's greater than because it said the top 10%. So I know that this is 0.10. So since I have what's on the inside and I want what's on the outside, I have to use inverse norm because I'm going backwards. So I'm going to do inverse norm for 0.9 because the area to the left is 0.9 with a mean of 81 and a standard deviation of 5. So second vars, inverse norm, 0.9, 81, 5, and I get 87.4. So in other words, the people that scored 87.4 or above are in the top 10% of the class. Now, just to show you how you can make a mistake and kind of catch yourself, if I did second vars and I put in the 0.1, that would be 74.6. And so if you look at your normal curve, 74.6 would be down here. And that wouldn't make sense that my X value for the top 10% was below the mean. So hopefully you will be looking at that whenever you are assessing your answers to see if they make sense. And that ends section 5.3.